Hi guys, this is for module 15.3, tangents and circumscribed angles. The essential question is, what are the key theorems about tangents to a circle? Shortest answer, I know, is if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Conversely, if a line is perpendicular to a radius at a point on the circle, the line is tangent to that circle. Also, the circumscribed angle of a circle and its associated central angles are supplementary. So, tangent is a new definition. All right, it's for trig. We've used it for trig before. So, that is something to note. And you get to finally see what tangent means. And perpendicular, don't forget what that means, right? It intersects at a 90-degree angle, right? So that's perpendicular. Point of tangency, that's a new word, and I'll get into that. And then conversely, that means, again, just reverse of the statement. All right, so if P then Q, then, well, if Q then P, right? Um, Circumscribed, that's another word. So we already saw inscribed. Circumscribed means an angle outside. So in this context, circumscribed angle means outside of the circle. Okay, and then supplementary, you already know, means 180 degrees. Okay, so first things first, some definitions. Tangent is a line in the same plane as a circle that intersects a circle exactly at one. Sorry, that's supposed to be a 1 there, or an E. 1 point. The point where a tangent and a circle intersect is the point of tangency. So tangent is basically this line, okay, intersects at 1 point, okay, that is your point of tangency. Now, when it intersects that point, when it hits that circle, it hits perfectly at a 90-degree angle in reference to your center, okay? So when they're talking about the radius and whatnot, they're talking about from the center to that point of tangency, and that always is a 90-degree angle or right angle at that point of tangency. Okay, so it's basically like a graze. That line is grazing that circle. All right, so the theorem itself for tangent radius theorem, and I kind of drew it already on the last example. If a line is tangent to a circle, then it's perpendicular. So again, 90 degrees. All right. Now conversely, okay, so again, the converse is, well, we had if P then Q. The converse is really just, well, if Q then P. All right, and that's really all the converse means. So more specifically, okay, the theorem already said if the line is tangent to the circle, then it's perpendicular to the radius. Well, now if we're perpendicular to the radius, then we are tangent to that circle. So basically, it's like, yeah, it's tangent, therefore it's 90 degrees. And then the converse is just saying, well, if it's 90 degrees, then it's tangent. So it's just reversed on how it's saying it. All right, so a circumscribed angle, this is a new definition. A circumscribed angle is an angle formed by two rays from a common endpoint that are tangent to the circle. That's really important. That means if you look at this example, this line is tangent, so it's 90 degrees from the radius, as is the other line. It is also tangent to the radius. Um, and this is the circumscribed angle right here. Now, basically what they're saying with the theorem itself for circumscribed angle theorem is if you have a circumscribed angle of a circle and its associated central angle are supplementary. So basically what they're saying is, yeah, you got these two 90-degree angles, right? And let's say this angle, this central angle right here was, let me make a number up, 80 degrees, okay? That means this angle out here, this circumscribed angle, has to be 100 degrees because they have to add up to 180 degrees. That's what the theorem states. Okay, so again, example 2, if your central angle here was 60 degrees. Okay, your circumscribed angle has to be 120. All right, because again, these two angles have to be supplementary. That's the circumscribed angle theorem. All right, your turn number one. Again, you should already know how to set this up. You already know based upon the theorem what angle NPM plus NQM should add up to. Okay, that was on the last slide. And then just solve for x. All right, and then once you get x, plug it back in. And the question is find all the angle measures. I'll tell you what, I'll make it easy. Uh, here's two of your angles. They're 90 degrees. All right. I know you're thinking, you're like, gee, thank you, Mr. Webb. You're welcome. Did half the work for you already. All right. So again, line NQ and MN are, or those segments are both tangent lines. All right. So example 3. Something else to note is if you have these two tangent lines. Okay. So for example, AB and line segment AB and line segment AC, they're both tangent lines. Okay. Or line segments at least. That means they do intersect at 90 degrees. Fun fact: if they're both tangent, both sides are going to be congruent to one another. Okay, so that means that AC should have the same length as AB. So knowing that, you can actually find the missing side if you wanted um, with that logic. So to solve for x type deal, we would just do regular algebra, right? X equals 12. If you plug it back in, you should realize that AC is 16, as is AB. So that's just kind of like a little fun fact about congruency of tangent lines in dealing with a circle. So with that idea, go ahead, solve for x, plug it back in, and then I want you to find me the length of AB, and I want you to find the length of AC. All right. So here's your homework, page 809 through 812, numbers 8 through 19. Um, I think you might start on 810 around there, okay? Because I did change the numbers, so it's 8 through 19, okay? And let me know if you have any questions or concerns, and then just come see me. Okay, guys, I'm out.